All right, I've got one slide to share some thoughts about logarithmic differentiation, okay? And these occur when you have items that look like this. And if you look at this equation, you notice that you have an x in the base, and you have an x where the exponent is, right? And there's different rules for each type, whether you have variables where your base is and where your exponent is. So how do we treat a problem like this? Well, here's what I do. If you have the variable in both locations, I'm going to take the natural log of both sides. Okay. And from this, what I'm going to do is I'm going to use the rules of logarithms, okay, to move my 3x out to the front. Right here, this will stay the same. Okay, and then from here, I'm allowed to now take a derivative, all right? So the derivative of y is 1 over y dy dx. And this here will involve your product rule. So first times the derivative of the second plus the second times the derivative of the first, which is a 3. And that's as much as you can do there. And now I'm going to simplify this a little bit. There's a plus sign there. Let's put 3 natural log of x in that order. And 3 over x times 1 over x is just 3. Okay, now, remember the goal is to get dy dx by itself. So I'm going to get rid of that 1 over y. And I'll do that by multiplying. Okay, now for most, you're like, well, that feels like it's done. And it kind of is. However, we know what y is. Okay, and I can write this all in terms of x. Y is this item, okay, to the right of that. Okay, so that is x to the 3x power. You are done. Okay, so again, I oftentimes do logarithmic differentiation when you have bases and powers that are both the variable that you're taking a derivative of. All right. Okay, same idea here. There is so much stuff here, and I don't want to do this by quotient rule. That's just kind of messy. All right, so what I'm going to do is I'm going to take the natural log of both sides, which is the natural log of y, equals the natural log, and then I've got this big monster. It's x minus 1 squared all over the square root of x squared plus 1, that piece square rooted, okay? All right, now, from here, based off my rules of logarithms, right, I can separate this into two pieces. I could say this is the natural log of x minus 1 squared. Let me erase that. Okay. And then remember, you can break this into two logarithms, provided that you put a subtraction sign in between. And let me write this as a fractional exponent too. This is really x squared plus 1 to the 1/2. All right, now from here, I can now take a derivative, okay? So natural log of y now becomes a 1 over y dy dx. Natural log means you're going to put everything here on the bottom. Okay. The natural log will go away, but then you have to take the derivative of the bottom, okay, which is 2 times x minus 1 to the first power times the derivative of the inside, which is just 1. And then the same thing here. Okay, I need to put this item on the bottom. Okay. However, I also have to take the derivative of this. Okay, so this part, I forgot the half, I'm sorry. I'll take the derivative of it, which is 1/2 times x squared plus 1 to the negative 1/2 And then chain rule, derivative of the inside is 2x. Okay, so careful on that. Everything in the back behind the natural log will go in your denominator, and then you have to take the derivative of that piece. Okay, so that's kind of a lot of work. All right, so 1 over y dy dx equals, now you can simplify a little bit here. I would again say on an AP exam, this is free response, you can stop here. Okay, that would be appropriate. But we'll clean this up just so it matches maybe the back of your book and just so you can get a better understanding of what this may look like or feel like. There's an x minus 1 on both your numerator and denominator, so they will each cancel out with 1. And then I'll subtract, and the 1/2 and the 2x are going to go away. At least the coefficients will, so that will just give you a negative, or subtract x. And then you can move this to the bottom, okay, so you already have an x squared plus 1 to the 1/2. If you want to take this numerator, put it in the denominator, you can, so that you can have a positive power, okay, so, and that'll give you x squared plus 1. And you could call it to the, well, 1/2 plus 1/2 is 1, to the first power if you want, or you can leave it as is, okay. I'm not going to create a common denominator. Why make this look uglier? But I do need to get rid of this 1 over y, and it's the same procedure as before. We will multiply both sides by y. And so you'll get a dy dx is equal to, and I'm going to recopy this, 2 over x minus 1 minus x over x squared plus 1. And then the y that I multiply both sides by, that's the same thing as the original problem. Okay, so I'm going to rewrite that off to the right with a big times sign. That's x minus 1 squared all over the square root of x squared plus 1. Okay, and that is it. All right. If you have any questions, you let me know, and I'll be happy to get back with you quickly. Thank you for joining me.